We proceed in calculus theorems. Okay, so we will proceed in calculus theorem and then we will continue our discussion. I was saying more about the Cauchy mean value theorem and it is amazing, mind blowing. Cauchy mean value theorem. In single variable, I was seeing and it is really amazing. If I have a point A and B on x-axis, then I will have another point called FA and FB on the curve. If this is x-axis, then there will be a curve like this. If this is x-axis, then this is y-axis. If this is x-axis, this is y-axis. I draw a curve in xy plane. Equation of this curve is function over x equal to what? It can be sin x. Function over x equal to sin x. This can be one of the equation of the curve. Function over x equal to sin x. Okay. If that is the case, then if I have point A and B on x-axis, A will, if I draw a vertical, it will touch the curve. If I draw a vertical at B, it will touch the curve. Consider this curve is fx. There is another curve called gx. So above the x-axis, I have two curves. One curve is fx and another curve is gx. Gx and fx. So gx and fx are two curves above the x-axis. I have 2 points on x-axis. One is x equal to a, x equal to b. This is origin. From here, if I draw vertical, it is going to intercept fx and gx both. If I draw vertical from here, it is going to intercept fx and gx both. Okay, now if I there are four intersection that is happening in fx and gx. In fx there are two intersections. In gx there are two intersections. Understandable? This is x-axis, this is y-axis, this is origin. This is x-axis, this is y-axis, and this is origin. Now from y-axis, if this is xy plane, if this is xy plane, in the xy plane I have a graph called fx. I have a graph called gx. There are two graphs are there in this picture, fx and gx. If two graphs are there on the picture, now I have 2 points on x-axis, A and B. From A, I am drawing a vertical, it will hit fx and gx. From B, if I draw a vertical, it will hit fx and gx. I have 4 points of intersection on fx and gx. The intersection on fx and gx, 4 points are A, fa, B, fb. This is the 2 points on fx. On gx, A, ga, B, gb. Okay. Now if I connect the point A, fa and B, fb, if there is a curve like this, okay. So now consider this is fx and this, if this is fx, this is fx and this is x-axis. This is x-axis and this is fx. This point is A, fa and this point is B, fb. If I connect these 2 points, then there will be a line like this. Consider there is another curve called gx. There is one curve called fx. There is another curve above it called gx. And this point is A, ga. This is B, gb. gb is the height and A is the length from the origin. If I connect, there will be one line here also. Now the mean value theorem says that on this gx curve, there will be a point here called C, gc, where C is the intersection on x-axis and this is the height. Certainly there will be a point called C anywhere. C can happen And relationship will be if I draw tangent at C, this tangent, the slope means tan theta or theta angle. Tan theta is generally it is called slope dx by dx. Or if I draw a tangent line like this, then this tangent line will be exactly parallel to the line connecting A comma GA and B comma GB. This is Gx. Down the line, there is another function called fx. Fx can be different. Fx can be like this also, whereas gx can be like this. Now, in the fx, if I connect these two lines, these 2 points, this point is a comma fa, this point is b comma fb. Generally, we say x comma y, x comma y. X is a and y is function over a. Function over x at x equal to a comma fa, b comma fb. If I connect these 2 points, this will be a line. Now, if I start traversing from here to here as a tangential line, then one point will come called C. That C and this C is different. Or I will say one point will come called D. One point will come called D. D is the distance from the origin on x-axis, D comma FD, where the tangential at that point will be exactly parallel to the line connecting A comma FA and B comma FB. This is Gx, this is Fx. So in Gx, there will be a line point called C comma GC, where tangent will be exactly parallel to A comma GA and B comma GB. On Fx, another line, there will be a point called D. At that, the tangent will be exactly, this point is D comma FD. Tangent will be exactly parallel to the line connecting A comma FA, B comma FB. This is mean value theorem where C and D are different points. C is a point on Gx and D is a point on Fx. Separately, this is the mean value theorem. Fb minus Fa by B minus A. This is typically called gradient. Gradient means the tan theta of the, if this is fx and this is the line connecting these 2 points, then this is making angle with x-axis. Probably that angle is right now negative. If this is x-axis and this is the tangent, then this angle is negative. Tan theta of this angle is the gradient, that is dfx by dx at x equal to d. Means fb minus fa by b minus a is equal to is equal to is equal to d of fx by dx at x equal to d. Similarly, gb minus ga by b minus a is equal to dgx by dx at x equal to c. Make sense? Okay, if I divide both concepts, okay, what is common here? A and B are common, whereas C and D are not common. A and B, we have taken point A, we have taken two interception, and point B, we have taken two interception. Point A, we have taken two interception, and point B, we have taken two interception. Okay, so A and B is common among fx and gx, but on gx, the point where the tangent is parallel to this is C, where on fx, the point at which tangent is parallel to this is is point D. Now, if I divide both the stuff, then it will become fb minus fa by GB minus GA, because B minus A will go away. FB minus FA by GB minus GA is equal to dfx by dx at x equal to D divided by dgx by dx at x equal to C. This is not the Cauchy mean theorem. Cauchy mean theorem say that it is, I believe it is all right what I am saying. So if I don't know where from the other curve I can bring in. Okay, I think people would understand this is fx and this is another curve called gx. Gx, I have a point C here. C means if I draw a vertical on x-axis, it will be C. At C point, if I draw a tangential line, that will be parallel to this line. I have another curve called fx, and there is another point. There is another point called D, and this D, if I draw a tangential line, this line will be parallel to line connecting these two points. But what is common between fx and gx? This snapshot, this is B and this is A, that is common. So the interception here on x-axis is common both places. But here the tangential line and here the tangential line C and D are different. Cauchy mean value theorem says that FB minus FA divided by GB minus GA is equal to FC DF sorry DFX by DX at x equal to C, any C, by DGX by DX at x equal to C. Make sense? Okay, so I'll repeat again. So Cauchy mean value theorem I have demonstrated. Mean value theorem says that FB minus FA by B minus A is equal to dfx by dx at x equal to D. GB minus GA by B minus A is equal to dfx by dgx by dx at x equal to C. If I divide both, it will become FB minus FA divided by GB minus GA is equal to dfx by dx at x equal to D by dgx by dx at x equal to C. Okay, where C and D are the point where it is parallel to the corresponding intersections. Okay, Cauchy mean value theorem says the left hand side is all right. FB minus FA by GB minus GA, that is all right, there's no problem, is equal to dfx by dx at any point x equal to B divided by dgx by dx at same point. Oh, I believe B slot I have taken. So I will say any point E f b minus f a. F b, if I take x axis and at x equal to B, if I draw a vertical and it is hitting point fx and gx, then height at fx is fb and height at gx with the x axis is gb. FB minus FA by GB minus GA. FB minus FA by GB minus GA is equal to dfx by dx at x equal to B, at x equal to E, some point E, dfx by dx at x equal to E divided by dgx by dx at x equal to E. Means it is, what I'm trying to say is that if I consider that this is tan theta. Okay, what this theorem says that if I consider this line connecting this is gx and this is the line that is connecting these two points. If I draw the characteristics of this line means vertical by horizontal. If I draw a horizontal line here, then this is the extra vertical. This vertical by horizontal. Okay, what is vertical? GB minus GA divided by B minus A. Okay, I have another function called fx, where this is fa and this is fb. Fb minus fa, this is this vertical, divided by this b minus a. Means more or less, okay, what I get here, tan theta. If this is the angle with x-axis or this is the angle with x-axis, then this is theta, tan theta. In this also, if this is the x-axis and this is theta, then this vertical by horizontal is nothing but tan theta only. If I divide tan theta of both, that is fb minus fa by b minus a, Or if I divide the vertical of both, because b minus a will cancel each other, fb minus fa by b minus a divided by gb minus ga by b minus a. B minus a will cancel each other. FB minus FA by GB minus GA means the difference in vertical what we are seeing in GB, and difference in vertical what we are seeing GX, and difference in vertical what we are seeing in FX. If I divide difference in vertical in FX, sorry, if I divide difference in vertical in FX divided by difference in vertical in GX, that will be same as there will be arbitrary point called E, E and GE. Oh, sorry. This way, if this is x axis, there is a point called E here. If I draw a vertical, this point is E comma GE. Similarly, if this is the case, then this is a point E, same point E. Then here vertical will be FE. Then Cauchy mean value theorem says that the difference in the height, that is FB minus FA, divided by difference in the height, that is GB minus GA, that will be same as there will be arbitrary point called E. Then dfx by dx, gradient at gradient at point E on fx divided by gradient on point E on gx. If I divide, that will be same. What I'm trying to achieve here. Consider this is gx and this is fx. This point is A on x-axis, this point is B on y-axis. These are same point here, this is fx and this is gx. Same point. Here fx and this is gx. Same point. Okay. Now this formula Cauchy mean theorem is saying that every point, if I take gradient, every point, this point at point A, what is the gradient? And in this curve at point A, what is the gradient? If I divide these two gradient, okay, keep doing for all the point in both curve and divide the gradient. One point E will come where this gradient and this gradient division will be exactly same as same as this height division by this height division. Okay, concept is we will proceed on this, but still we will proceed in the single variable to multivariable case, the discussion that we have started. How I can promote single variable to multivariable case. And today we will try to use it in calculation of surface area. Calculation of surface area. What we have learned till now. Okay, if I have a curve, consider this is x-axis. This is x-axis. This is x-axis, and this is the curve called fx. This is fx, and this is x-axis. This is y-axis. This is x-axis, and there is any curve called fx. Any curve called fx. Now, if I take any point here, then I can draw vertical. Make sense? If I take any point x here from origin, if I draw a vertical, it will touch this point and this height will be fx. That's why the curve is written as fx. Fx is nothing but height. Fx is not the equation of the curve. Fx is height, combination of all height in terms of a variable algebra. We call it fx. But otherwise, fx is a height at any point x on x-axis. What is the height? That is fx. That is fx. Now the question is, if I try to calculate the dfx by dx, dfx by dx means if I have any point x here and if I draw a vertical here, then at this point, if I move 1 unit, then how much I have to move how many unit I have to move in vertical. Understand it? If this is x, then this height is fx. If I move 1 unit along x-axis at x, then it will go up and it will hit 2 points. This height is fx, and this height is fx plus 1. If this is x, then this is x plus 1, 1 unit. This height is fx plus 1, this height is fx. What is the difference in height we see when I move 1 unit difference in x-axis? That difference in height, nothing to do with x-axis. If I move 1 unit along x-axis, how much I have to move along y-axis? If at any arbitrary point x, if I have height as fx, then if I move 1 unit along x-axis, then this is another point. From this point to this point, how much height I am seeing the difference when I move 1 unit? That is dfx by dx. What is the change in the height is dfx by dx. Makes sense? If 1 unit change is there, if it is x and this is x plus delta x, okay. If this is x, and if I move delta x, if this is x, if I move delta x, then this is fx, and this is fx plus delta x. This is x, then this is fx. If this is x plus delta x, then this is fx plus delta x. If I move delta x, then how much vertical I have moved? That is fx plus delta x minus fx. If I move if I move, now I can write, if I move delta x in horizontal, then vertical movement is fx plus delta x minus fx. If I move 1 unit, then fx plus delta x minus fx by delta x, that is dfx by dx. Means per unit movement along x-axis at any point x, if I want to see how much vertical is moving, per unit movement along x-axis at point x is dfx by dx. Makes sense? For delta x movement on x-axis at x equal to x, how much vertical has moved is fx plus delta x minus fx. Per unit movement divided by delta x, that is dfx by dx. So dfx by dx is nothing but how much vertical is changing if I move 1 unit of change at x-axis at x equal to x. That is dfx by dx. I am free to calculate dfx by dx at any point. Consider fx is sin x. Then dfx by dx will be cos x. Now every unit movement. Now if I draw a sin x, if people watching it, if I draw a sin x curve, this is typically a sin x curve. This is typically a sin x curve. If this is typically a sin x curve at pi by 2, I have a maxima. Pi by 2, I have a maximum is at this point nothing is changing. Here it is rising and then it is coming down. At maxima, there is nothing changing. It is a stagnant point. So at that stagnant point, dfx by dx should be 0 because vertical is not changing at that moment. If I have fx as sin x, then dfx by dx will be cos x. Cos x. Cos x means the if I'm trying to find the change in vertical per unit change in horizontal, then that is coming as another algebraic equation, and that is cos x. If I take at x equal to pi by 2, how much change we are seeing? Cos pi by 2 is 0 only. It is not changing. Whereas at 0, cos 0 will be 1. Maximum sin x is changing. Per unit change along x-axis is at x equal to 0, beginning 1. These are the concepts. Now I can rewrite as dfx by dx as d by dx I vector bracket close fx dot product with bracket I vector. Same. D by dx, d by dx I vector bracket close fx into fx dot product in another bracket I vector. Mean this is called gradient vector. D by dx is called gradient vector. How things are changing if I change along x-axis I vector. What things are changing? That is outside written fx. Means how height is changing. How height is changing with the movement of along x-axis. If I move along x-axis, how much height is changing? Makes sense? D by dx is the gradient vector change we see if I make change along x-axis. Change of what? Change of fx. Change in what direction? Change Dot product means aligned to what direction? Dot product means aligned to what direction? Aligned to I vector. Okay, means if this is the curve and this is x-axis, this curve is changing changing along x-axis. If I move along x-axis, how much curve means height? How much height is changing? Okay, how much height is changing of this curve? Dot product I along I vector. There is only one vector called I vector. Only there is no two vector. But two vector comes into the picture when there is surface. If there is a surface, then certainly two vector comes into the picture. Okay. What I'm trying to say is, consider this is xy plane. Consider this is xy plane. This is x-axis and this is y-axis. This is xy plane. On this xy plane, now things can move in a xy plane all around in two dimensional. Now above this xy plane, I have a surface. Above this xy plane, above this xy plane, I have a surface like this. I have a surface like this. Now the question is arising, how much now from xy plane, if I draw a vertical line, consider this down part is not there. I am drawing it. Consider this lower part is not there. Only upper part surface is there. This is invisible. Down part is invisible. Now from this xy plane, if I draw a vertical line, it is going to hit this point. Okay, this point. Consider this point is a point on xy plane called A. A is x comma y. On xy plane, I can have different point. There is one point called A, and coordinate of A is x comma y. Now from A, I draw a vertical line. From A, I draw a vertical line, and that vertical line hits the surface at this point. Makes sense? The vertical line hits the surface at this point. So this point, the height is function over A, where A is a point on xy plane. The question is arising, can you tell me this from here I am proceeding on this surface. From here I am proceeding on this surface. Which direction? I want change in the height. If this point is A comma FA, from this I am rising in the height. See, the height is rising. Height is rising. Can you tell me how much this height is rising? Someone will tell, I am fool or what? In what direction you are rising? If it was a single line, then I have only one path to rise. If there is one curved line, then if I have a point on the curved line, then I have only one path to rise. But if I have point on a surface, then I have so many paths to rise. I can rise like this, I can rise like this, I can rise like this. There are so many paths to rise. In which path I have to rise? Tell me. In which path I have to rise? That path will be guided through xy plane. This is what I am saying. If this is the point on surface, from this surface I am trying to climb. Like I am standing, consider, I believe people just show, if I am standing on a curved rope. Consider I am standing on a curved rope. This is a curved rope. Curve. This is a curve, and I am standing here. And then I have been asked to climb up. There is only one path I can climb. There is no two different paths. Make sense? I have to climb either I have to decline. Either I have to climb down or I have to climb up. But line is only one. There is no question is arising in what direction. It is only along x-axis only. But if it is a mountain, if I am standing on mountain, and then I have been ordered to climb up, then I will ask in what direction. Because I can climb in many directions. If I am standing on a mountain, somewhere on the mountain, and then I have been asked to climb. Can you climb on the mountain? Okay, then which direction I have to climb? Because climb will happen in many directions. Which direction? that direction will be guided by the xy plane. Which direction? Consider this is xy plane and this point is A. From origin, if I connect, then there will be a line, there will be a line, and that line, this point is A or x comma y. There will be a vector called xi plus yj. Now, if I continue this vector, then it will go like this. Make sense? There is a point called x comma y, coordinate of a point. Point is A. From origin, if I draw a line, then it will pass the x comma y. While it is passing the x comma y, it will proceed like this. This is called vector, that is xi plus yj. I'm asking, do one thing. When you are climbing on the mountain, now, the if from A, if I take exactly vertical line, then it is going to hit this point. This is A comma FA. Now, whenever you are climbing on the mountain, when you are climbing on the mountain, then with each step you are making, I'm going to draw a vertical line. Each step you are making, I'm going to draw a vertical line. And that vertical line will hit XY plane at a particular point. All those points, all the step you are climbing, all your footprint that will go on the XY plane, it must fall on the line that is xi plus yj. This is what I want. You have to climb on the mountain, on the path where each of your step, if I draw a vertical line down, it will make a point on xy plane, and that point will fall on a line connecting origin and point x comma y. It must fall on the vector xi plus yj. That is the question. How we can solve it? That is what it is arising. So the solution is that we will do whatever we have been doing in the single variable case. In single variable case, how we were climbing? Case, single variable case, if I take, climbing means what is the y? Climbing means what is the fxy in 3D? In 2D, what is y? At each moment, what is y? Make sense? If this is the curve and this point is y, then I'm climbing like this. What is new y? That is height. What is new y? That is height. What is new y? That is height. Okay, what is new y? That is height. Okay. Now, if this consider this is x and this is fx, then at this point I have a tangential line. Makes sense? Here I have a tangential line. This is not a straight line. This is not a straight line, curve line. At this moment, if I try to climb, I will climb in a straight line. Then I will come down here. Then I will try to climb in another straight line based upon what tangent we are seeing at each moment. So I will climb in a straight line. Then I will go to next point. Then again I will try to climb in a tangential line. Okay, if I want to see that equation, then it will be okay. Now question is arising, in what way I am climbing? That is d by dx I vector bracket close fx dot product with I vector. Means I am trying to climb. This says that the when I am climbing, the gradient means how vertical is changing with the change in x axis. That is called gradient. So that is dfx by dxi vector, dfx by dxi vector dot product I vector. Means the climb is happening along I vector. Makes sense? Now, if I want in 3D figure, this climbing will happen along xi plus yj vector, because this is what I want. Okay, here it is I vector dot product with I vector. The climbing is happening along I vector, but here it is climbing is happening along xi plus yj vector. Okay, only thing, if I used vector notation, I have to just replace whatever we are doing, whatever in vector, no need to panic. Vector says that if you are going for single variable to multiple variable, you are nothing doing else than you are adding coordinates. That's it. If things you are doing in single dimension along x-axis, you will add y-axis. That's it. So if I am saying our gradient vector is dfx by dx, our gradient vector is d by dx I vector. Then if I'm talking about 3D, one j vector will get added. So it will become d by dxi vector plus d by dy j vector. Means whatever we are trying to do in dual independent variable case, only new axes we will add. That's it. This is what vector technology. We are trying to achieve the whatever we want through vector technology. So vector technology says that if you want the equation in the fxy when someone is climbing, use vector. And wherever you are seeing I vector, you have to add j vector. That's so if it is d by dxi, you have to say d by dxi plus d by dyj. That will get added in bracket outside fx is there. Fx will become fxy because it is now variable of x and y. Dot product along I vector. Earlier it was along I vector. But now we are working along xi plus yj vector. So I vector will be replaced by xi plus yj. Makes sense? But xi plus yj should be unit vector divided by square root of x square plus y square. This is something that someone is trying to climb the mountain. Someone is trying to climb the mountain in a path that is guided by the xy plane, and the direction is a line connecting a 0 comma 0 on xy plane to x comma y. That is d by dxi plus d by dyj. D by dx got converted into d by dxi plus d by dyj. Bracket close, fx got converted into fxy. Dot product I got converted into xi plus yj because that is the direction. Divided by a square root of x square plus y square. Now I have a question now. Can I use this concept to find the surface area? Consider I have a line. How I can calculate the length of this line that is going from this point to this point? Can I calculate the length of this line from this point to this point? If I am able to calculate this, can I use same thing through vector technology to get the surface area of this surface? If there is surface here, and there are 2 points on xy plane A and B. There are 2 points on xy plane A and B. Between A and B, there will be a rectangle. If I map this rectangle on the surface, then what will be the area of that? I believe it is understandable. If there is a surface like this, and there is a point A and point B, then it will form a rectangle like this. If this is the rectangle, I will map this rectangle on a surface to a surface area. What is the area of that surface? Can I find this with a similar concept that if I have x-axis and I have a curve like this, and this is a point A and this is point B. If I map this point A and B on this curve, then what is the length of this curve? Can someone try to find it through vector technology? I believe I thought of starting at least something I can do. Now consider there is one vector that is connecting origin and this point. Makes sense? There is one vector that is connecting origin and this point. Makes sense? Okay. Consider this is point is x. This is x and this is fx. Then what is this vector? This vector is xi plus fxj. Makes sense? This is x and this is fx. This vector equation is xi plus fxj because this point is x comma fx. Now I move delta x, then I am going to come to another point, and this point is x plus delta xi comma function over x plus delta xj. This is one vector, this is another vector. If I take difference of these two vectors, then I'll get vector that is another vector that is connecting these 2 points. One point this and one point this. If I want this vector, then I can subtract this vector and this vector. I'll get this vector. So this vector I am talking is nothing but x plus delta xi plus f x plus delta xj minus xi plus fxj. If I settle it down, it becomes delta xi plus fx plus delta x minus fxj. That is the vector. If I calculate magnitude of this vector, it will give me the length. Idea is to find the full length, but let's try. So length of this, the vector representation of the tangential vector. This is better, I would say. If there is a tangential vector at this point, this tangential vector is represented as delta xi plus fx plus delta x minus fxj. This is tangential vector. If I take out delta x, it will become I plus fx plus delta x minus fx by delta xj. Bracket close, delta x is outside. Fx plus delta x minus fx by delta x is dy by dx1. So I can say that tangential vector equation is I plus dy by dxj. Bracket close, delta x or dx. Now to calculate the length of this because of delta x, how much length I am seeing here? A length will be magnitude of this vector. That is 1 square plus dy by dx whole square, a square root, whereas dx is outside. Makes sense? Now, if I want to add this for all the section till I reach here, that is nothing but dx integration from x equal to point A to point B, means point A to point B, or x1 to x2. The square root of 1 square plus dy by dx whole square, dx will give the length of this line. Can I use this technology to calculate the surface area of the surface through vector? Because vector way we are seeing that directly I can climb on the multivariable case. Only thing is extra axes need to be added. Here we have I and j. In 3D, there will be k vector one. I have to add one k vector. That's it. Otherwise, things will be similar. Can someone try? Can be taken as an assignment. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610.